We will be doing chapter number 1 for General Chemistry 101. The title of the chapter is Basic Tools. This particular chapter, for convenience, has been divided into 4 different units. First, we'll study the general chemistry and its methods. Then we will study properties of matter. Third, we'll study the energy and its components. And fourth, we'll study the measurements, tools for quantitative chemistry, that is quantitative chemistry. Now, I'm going to go through the PowerPoints. As I go along, I just need to tell you the following things. Once the 4 subunits are completed, at the end of each subunit, you will find review questions in order to ensure that you have comprehended the material before going forward. And with that, I'm going to start. Chemistry, the first part is chemistry and its method, sustainability and green chemistry, classifying matter, elements and compounds, properties and changes, basic principles involved in energy and quantitative chemistry. The first question that comes up is, what is chemistry? Chemistry is the study of the properties, composition and structure of matter, physical and chemical changes it undergoes, and the energy liberated or absorbed during those changes. In order to study chemistry, before we start the definition itself, chemistry is divided into 2 aspects. One is the qualitative aspect, and the second is the quantitative aspect. First, we are going to do the qualitative aspect and then get into the quantitative aspect. As we study chemistry, we have to understand that we are studying matter. Matter we define as anything that occupies space and it has mass, and mass is the measure of the amount of matter that an object contains. Before starting any studies, we need to know what are the methods that are involved in chemistry. Just like in any scientific study, it involves the explanation or prediction of a tentative observation, and this is called as hypothesis, a concise verbal or mathematical statement showing the relationship that is always the same under any conditions. That is the law, and the theory is a well-tested unifying principle that explains a body of facts and the laws based on them. Theories can also suggest new hypotheses that then can be tested experimentally. Qualitative observations are considered as those that do not involve any numbers, color, and physical appearance. State something is hot or cold without specifying a temperature. Identifying something by smell. And finally, no measurements are involved. The goal of science is prediction, control, understanding, and explaining the facts that are observed. One of the things about science is that experimental results should be reproducible within a limit of a small amount of error. These results should be reported in scientific literature in sufficient detail to be used or reproduced by others. Conclusions should be reasonable and unbiased, and credit should be given where it is due. Reproducibility of results. Report in detail so that others can use or reproduce them. Papers reviewed by experts in field to ensure proper conductance of experiments and logical conclusions are drawn. Conclusions, again, must be reasonable and unbiased, and we have to give credit where they are due. Now, this particular topic, chemistry and Sustainability and green chemistry is really very important in today's world. Generally, we have to make sure that we prevent waste. Synthetic methods should maximize materials. Chemical synthesis should reduce toxicity. Energy requirements should be minimized. Raw materials use should be renewable and practical. Green chemistry is an application of chemistry and chemical insights into developing protocols and practices which reduce environmental pollutants based on the 12 principles as put forward by Paul Anastas and John Warner in 1998. Prevents waste rather than create and clean waste. Devise synthetic methods so as to use all the materials to produce final product. Methods use and generate chemicals of low or no toxicity to human and environment. Design chemicals that function effectively while reducing toxicity. Minimize the energy requirement to lower economic impact and as well as environmental impact. Carry out experiments at ambient temperature and pressure, generally considered as room temperature. Use renewable raw material whenever economically and technologically possible. Develop chemical products which after their use do not persist in the environment nor produce toxic products. Choose chemicals in processes that reduce accidents, explosions, and fire. With those general concepts in place during this particular study, you will be equating the course content with the lab content, which must run concurrently. So when you register for this particular course, make sure that you register for the lab itself so that you can have a real good understanding of the content as well as the application. Now we start going into matter and energy interactions. Matter, quantity of a substance in a given material, usually in the form of mixtures. Few occur as pure substances. They can exist in different states due to the amount of energy possessed. Therefore, when we classify matter, we take into consideration two forms of matter definitions are there, one based on energy and the other based on composition. So according to the physical state, which depends upon the amount of energy possessed by a body, the physical matter can be defined under 5 states, of which 5 states, and they are the plasma state, gas state, liquid state, solid state, and the condensed state. Plasma state consists of highly energetic particles. Gas state is individual and it can move around by itself. It occupies the entire volume of a container. Liquid state is free to flow and occupies the shape of the container. A solid is a rigid structure and does not move very much and has much less kinetic energy content. While the condensed phase has extremely low energy. So the physical state of matter is classified based on the energy and the kinetic molecular theory. When we classify according to the composition, we start with the mixture and then we designate what type of mixtures we have and how we can purify them, and then identify each of the component that is present. Classifying matter, you have an example of solid, liquid, and gas. Solid has a definite shape, definite volume, low kinetic energy, Liquid has an indefinite shape, definite volume, intermediate kinetic energy. Gas, indefinite shape, indefinite volume, and the highest energy state. All the states that are there is explained on the basis of small particles that are present and are in constant motion, either in the form of atoms, molecules, or ions. In solids, the atom particles are packed closely in a regular array. They vibrate about their average position. Liquids and gases, they are fluids. Particles are randomly arranged, not confirmed, so can move past one another. Under normal conditions, particles of a gas are far apart and move rapidly, colliding with one another and the container, thereby filling the container. The force of attraction between solids and liquids are much higher than that in gases and plays an important role in determining the property of the elements, particles that are present. Now, because we are talking about very small particles, we have to understand what the levels of the particles are. Macroscopic, this is the world of experiments and observations. For example, chemical and physical processes. Submicroscopic or particulate level, this is a level of individual particles that make up all matter. For example, atoms and molecules. A scientific model helps us to visualize atoms and molecules. Atoms, the smallest unit of an element that has all the properties of an element. Molecules, the smallest particle of a pure substance that has all the properties of that substance. It may contain more than one atom and more than one element. A molecule is the smallest unit of a compound that retains the characteristics of the compound. The composition of molecules is given by the formula of the compound, which designates the type of element and the number of atoms of each element. When we classify matter, we start looking at how do we start separating them. Generally speaking, matter occurs in nature in the form of a mixture. And as we have already defined, matter occupies space and has mass. So we separate them out into physical mixtures and pure substances. So physically, we can separate these two into mixtures and pure substances. The pure mixtures are considered as homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures have uniform composition. Heterogeneous mixtures have non-uniform composition. A pure substance, it has fixed composition and cannot be further purified. They can be divided into compounds, which consists of elements in fixed ratio, and they can be chemically separated into or combined into by using elements. Elements cannot be subdivided by any chemical or physical processes. So in general, a combination of two or more pure substances, you get homogeneous and non-uniform composition. So homogeneous is uniform composition, heterogeneous is non-uniform composition. The characteristics of all the matter that is present, we have shown in this particular slide so that you can have elements, compounds, homogeneous mixtures, and heterogeneous mixtures. Mixture has no fixed composition. Its composition can vary over a broad range. Solution is a mixture that is homogeneous, which means that its compositions and properties are the same throughout. An example of a homogeneous solution is a salt solution. Heterogeneous mixtures varies in composition and or properties from one part of the mixture to another. For example, your cereal. Raisin Bran cereal that is there. So you have raisins and cereal in it. A homogeneous mixture consists of two or more substances that are uniformly distributed down to the molecular level. No amount of optical magnification will reveal different properties in different regions of a homogeneous mixture. A heterogeneous mixture does not have uniform composition. Its components are very easily visually identified. When separated, the components of both the types of mixtures, yield pure substances. And this is a separation technique for a heterogeneous mixture such as sand and salt. You can use the filtration technique, and this is called as gravity filtration because the size of the solvent, which is water, is much smaller than the openings on the filter paper, so that the solid, when the mixture is poured through, the solid settles on the top and the solution, the water component settles at the bottom, is much purer than what it was at the beginning. Now we classify matter, substance, type of matter with fixed composition that does not vary from sample to sample. That is what we say in chemistry when we mean a substance. Elements, a substance that cannot be broken down into smaller parts. Compound, a substance made up of atoms of two or more elements with the different kinds of atoms combined in their fixed proportions. Mixtures may be separated by physical properties. The physical properties is density, which can be used, decantation and centrifugation, boiling point, distillation, state of matter, filtration, intermolecular forces, chromatography, vapor pressure, evaporation, magnetism, magnets, and solubility, filtration. Now, this is a self-study. You can answer this question by yourself. And so now we come to pure substances. A pure substance has well-defined physical and chemical properties. Pure substances can be classified as elements or compounds. Compounds can be further reduced into two or more elements. Elements consist of only one type of atom. They cannot be decomposed or further simplified by ordinary means. Element cannot be converted to a simpler form by a chemical reaction. Example, sodium, helium, gold, copper. Compound combination of two or more elements in a definite proportion, reproducible way. Example, water, H2O. Whether you get water from a pond, rainwaters, or water from snow, they all have the formula H2O. Now, self-study. These questions, please answer these questions. And then at the end of it, this will lead to our unit 2, which defines elements, compounds, atoms, and molecules. With that, I'm going to stop my share.